This segment is about nomenclature, and nomenclature is how do we name compounds, either ionic compounds that are held together with ionic bonds, and also how to name molecular compounds held together with covalent bonds. So here, naming compounds is important. It allows everybody to be able to talk about the same thing, and then when you hear a name, you have an idea of the chemical formula. Or if you see a chemical formula, you can see the name so others can understand what you're talking about. So this is the plan for today. We're going to start with the ionic compounds and nomenclature, and then we're going to move to molecular compounds afterwards. So let's see what we've got. So the first thing to keep in mind, and I'm going to put my favorite periodic table. So when we want to get information about compounds, the best place to go is our periodic table. And I'm going to take a moment and put the English version here for you to see. Perfect. So we have done a video on the periodic table and what information it has for us. So here we have on the left side the alkali metals. We have the alkaline earth metal here. In the middle, we have the, we call them the transition metals. And then if you go towards the right, we have here the noble gases. And right here in the green, we have what we call the nonmetals. So here, when we think of an ionic compounds, this is the first distinction. An ionic compound is made of one or more metal ions with one or more non-metal ions. So that is the first thing here. So let's look at an example to start with. So let's see. So when you have NaCl like this, or you have MgO like this, or you have, let's see if I can, Le2S like this, why not? And we have K3N. I think we're going to start with these four. So here, let's see if I can put the two images together so we can see. Oh, perfect. Look at this. So when you have sodium, sodium is located, it's located right here. So here you have an example of what it looks like. So sodium is related right there. We have magnesium that is right here. You can see the Mg here for magnesium. We also have lithium and potassium. So we have lithium, which is located right here, and potassium that is located right there. These are what we call metals. Now, with those metals, we have chlorine, oxygen, sulfur, and nitrogen. Where do we find those? So if I look on my periodic table, and if you want a bigger example, so there you go. We have nitrogen that is right here. So you can see here with the symbol N. We have oxygen right here. We have chlorine right here. And we have sulfur right here. So we have on this side what I call, so let's see, I have ionic compounds. And the reason for that is that we have a metal and a non-metal. So that's the key part here. So how do we name those? In order to name about an ionic compound, we always start with the metal, and then we go with the non-metal. So let's see how it goes. So we have, oops, look at this. It happens. So here the first metal is sodium. So we have sodium. Sodium what? We have here chlorine. So here what is interesting, some people say, well, we have chlorine like this, but when we are naming a compound, we're not using the word chlorine because chlorine refers to an element. We are changing the ending to end in IDE. So here we have sodium chloride. Here for the magnesium and the oxygen, we have magnesium, which is the metal. So let's see if I can write it at the top here. We always start with the metal, and then we have the non-metal. We have magnesium here, and then we have oxygen. So oxygen is the name of the element. In order to have the nomenclature or a name, we want it to end with IDE. So what it ends up being is like this. Magnesium oxide. That means here that we have magnesium and oxygen. We have two more. Li means lithium. Lithium what? We have here sulfur. It becomes sulfide. Sulfide. Like this. And here we have potassium and nitrogen. And here we have potassium. Potassium what? Potassium, we have nitrogen. We want it to end with IDE. It becomes nitride. So here we have potassium nitride. Now, you have to keep in mind that the metals that I've used so far are part of the alkali earth metals and the alkaline earth metal and the alkali metals. So if you look here, that means the first two columns right here. So these always have the same charge, because when you have ionic compound, you are working with ions, and the ion here of sodium is always a plus. With magnesium, it's always 2 plus. Lithium and potassiums are always positive. When we have here the non-metals, so here the metals are givers of electrons, the non-metals want to receive electrons. Chlorine is a halogen. It will accept 1 electron. Oxygen will accept 2 electrons. Sulfur, 2 electrons. And here we have nitrogen that will receive 3 electrons. So these are what we called neutral molecules, because a plus and a minus has an overall charge of 0. 2 plus and 2 minus, an overall of charge of 0. Here we have lithium that is plus 1, but because there are 2 lithium, we have a total of 2 positive charge that will neutralize with the 2 negative of the oxygen. And here we have nitrogen that has a negative 3. In order to get 3 electrons, it will get 1 electron from 3 of the potassium to be able to become neutral. So here I'm going to see if I can put a card here, or to be a video at the end. I will explain what are ionic compounds, so that some of you can, if you need some refresher, to know how come some of these metals have a positive charge and why non-metals have negative charge. So that's something to keep in mind. And that's the first thing we need to know about ionic bonds. Now, there's another group of metals that we have in our periodic table. So when you have a periodic table here, you have what we call the transition metals. So the transition metals are interesting because sometimes they can have different positive charge as ions. So let's see, what does it mean? So I'm going to focus today on copper right here, and I'm going to focus on iron today. So keep that in mind. These are the 2 that I will look into. So let's see if I can make a note on the board. So I'm going to use, let's do it in blue. It worked well earlier. So we have here copper sulfide, an iron oxide, and an iron oxide. So let's see what is happening here that is interesting. Here we have ionic compounds. How do we know? We have a metal and a non-metal. If you don't believe me, let's go to our periodic table. We have here copper, that is right here, part of the transition metals, and we have sulfur, that is a non-metal. We have iron oxide. Iron is a transition metal, and then we have oxygen, which is a non-metal. So we know that we have ionic compounds. Perfect. So let's double check here what we've got. Because we have a copper and a sulfur, I'll start with the metal. So we have copper. Copper what? Copper copper sulfide. I know that this is sulfur, but when we use nomenclature, we want to finish with IDE, like this. For this one here, I have copper and sulfide. So here I end up with copper sulfide, like this. So the issue with this one is that we have copper sulfide and copper sulfide. So that's easy. But we have the same name for two different molecules. Here we have one atom of copper with one atom of sulfur, and here we have two atoms of sulfur. No, two atoms of copper with that one atom of sulfur. So how is that possible? So let's see. Sulfur, like oxygen, have usually a two negative charge. So if it has a two negative charge, and we know that we have neutral molecules, that means here that the copper needs to have a two positive charge. That's something to keep in mind. Now, here we have the sulfur, which is also two negative, but here we have two atoms of copper. In order to have a total of 2 plus, but I have two atoms of copper, each of the atom of copper will have a charge of positive 1. So 2 ions of copper with positive 1 gives me 2 positive. That will neutralize here the 2 negative of the sulfur. So here we do have a copper sulfide, but there's a difference in the charge of the metal. And that's the trick for this one. What we do is we add a Roman numeral to identify the charge of the metal. So here, because the charge is 2 positive, we will have a copper 2 sulfide. Because here the charge is 1 positive, we will have a copper 1 sulfide like this. And that is how we can use nomenclature for the ionic compound with the transition metals. Now, this trick here was created or was put together with the scientists, and we called it the stock notation. So if you want to do research, you can look into that. So it's the stock notation like this. So that will be useful, especially for people that are looking for the science of the history of science. It's always lots of fun to do. Now here we have 2 more ionic compounds, and let's see what they are. I have iron and oxygen. Therefore, I have iron oxide. We have here iron and oxygen. I have iron oxide as well. Okay, the interesting thing that we have here is that we have 2 compounds that are called the same, iron oxide, but we have 2 molecules that look completely different. So here there's an issue with the naming. So here we need to figure out how we can differentiate them. So let's see. We know that the oxygen has a 2 negative charge, and that's for the basis. So when we start chemistry, if it has a 2 negative charge, in order to have a neutral molecule, we need a positive 2 charge for the iron. So this is great because 2 positive and 2 negative gives us a neutral molecule. So here, as we did with the copper sulfide, we have the iron that has a 2 plus, and to follow the stock notation, we have here iron 2 oxide. Now the question is, what is the charge of the iron here? So let's see. If I have the oxygen, we know it's 2 negative. Now the interesting part is that because I have 3 oxygen, so 3 times 2 negative, I have somehow 6 negative charge from the oxygen. That means that if I want a neutral molecule, I need to have 6 positive coming from the iron. But because I have 2 iron ion, then that means that each of the iron ion would have a charge of positive 3, because 2 of those will be 6 plus, and then 6 plus and 6 negative will be able to even out. So that's a great thing. So now we know that the charge of iron is 3 plus, and therefore we can put a Roman numeral here. So this is what we call iron 3 let's start again. Iron 3 oxide compared to this one, which is iron 2 oxide. And that helps us here with the copper 1 oxide. It's not the number here that we are interested in, it's the charge of the metallic ion. And here I have a copper 2 sulfide because the charge of copper is 2 positive. And that's how we can use the nomenclature for ionic compounds. And it's always exciting. We have here someone who just put a good morning. So good morning, John Kagger. Voila. Welcome to our live today. If you have any questions about science, don't hesitate to put them in the comments below, and we can be able to answer your questions. But before we end this segment on ionic compound, I just want to have a quick review. Here we have these words that ends in ID. Can we make a list of these words to help us? And before we go, let's see if we can go back to our periodic table. So let's see. Perfect. So I'm going to just erase this portion right here. So when we have our periodic table, and we know that we are looking for the anion first, or the negative ion, we have in the periodic table something. Let's get a fun color. So we have here fluorine, which is a halogen. We have chlorine, we have bromine and iodine. We also have oxygen and sulfur. We have nitrogen and phosphorus. Put carbon here as well. Like this. Perfect. So here, these are the first elements that are nonmetals that are part of the 21st elements. So here we have these, and how can these anions or negative ions be called for nomenclature? So we're going to make a list of these names to help us. Oh, look at this. It was very small, hard to see. So when you have carbon here, the carbon will be, because we know that all the words end with IDE, it will be something called carbide, like this. The nitrogen we mentioned earlier is nitride. We have oxygen, which is oxide, and fluorine, that is fluoride. We have fluoride, like this. Does that make sense? Can you see that? Okay, that's pretty close. Okay, so we go here, we go there. So under nitrogen, we have phosphorus. So here we have phosphide. You see, I think I'm going to restart this part here so that we can have a better look. We're going to make a list. I think it will be easier. So the carbon here becomes carbide. The nitrogen is nitride. Phosphorus is phosphide. Like this. Then we have these ones here. We have oxygen, which is oxide. And here under we have sulfur, which is sulfide. And as you can see, we always have the ending that helps us realize that it is part of the name of a compound. So let's see if we can look at the halogen here. We have fluoride, we have chloride, we have bromide, and we have iodide. So when we are naming ionic compounds, we always start with the metal, and then we follow with the non-metal. The metal, it keeps its name, so lithium, lithium oxide, and every time we have our negatively charged ions, our non-metals, they all end in IDE to have something that is always the same to help us. And that, I hope, will help you understand how we put the names together for the ionic compounds. And guess what? In the next video, I'm going to show how these can actually help you with naming molecular compounds. And that will be the next video. On this, I'm going to put here a link to a video related to what are molecular compounds. I'm going to put it here. So if you have more questions, you can see that question. You can have your questions answered right here.